Okay, we're going to talk about simplifying and doing a variety of simple operations with rational expressions. So we're going to start with the document that looks like this. We're going to do many of the first few pages on this, and then I'll do the rest of it in another video. Okay, so we're going to start with example 1. When you are confronted with a rational expression with polynomials on top of other polynomials, what you need to do is factor top and bottom. So this is a trinomial. We'll factor as x and x. 2 factors of negative 15, that the negative 2 are negative 5 and positive 3. And then over here we got x and x. 2 factors of 12 that to 7 are 4, or 3 and 4. Then what you do is you look for what is common to both of them, and you cancel it. Common to top and bottom, and you're left with x minus 5 over x plus 4. Okay? Now we're not going to do all of these. I think I'll take a look at example 2. So, example 2 is 2x squared minus 8 over x squared minus 3x minus 10. We can factor 2 out of this, and that gives me x squared minus 4. Down here, x and x, I need 2 factors of negative 10 that to negative 3, that's negative 5 and positive 2. But this also is factorable as a difference of squares. The square root of x squared is x. Square root of 4 is 2. So plus 2 minus 2. This one doesn't change. X minus 5, x plus 2. Cancel, cancel. And we end up with just 2, x minus 2 over x minus 5. Okay, and you can leave these in factored form. We're going to skip example 3, but we are going to talk about example 3, and we're going to look at example 6. We're going to skip example 3, 4, and go on to example 6. So example 6, x minus 3 over x squared minus 3x squared plus 5x minus 15. All right, now for complicated factoring, folks, you don't have to do it right within the fraction. What you could do is you could factor them off the bottom, the side, whatever. So this can't be factored, but this, and this is x cubed, I apologize. What we can do is factor the bottom separately. So this is factorable by grouping, so I'll take an x squared out of the first two. And that leaves me x minus 3 over here. Now for these two factors, they both have a 5 in them. So x minus 3 when I do the division. Because 5x divided by 5 is x, minus 15 divided by 5 is minus 3. Okay? All right, and then this becomes x squared plus 5 and x minus 3. Okay? So I have x minus 3 over x squared plus 5 and x minus 3. Now if you'll notice, the top and bottom both have an x minus 3 in them. So we cancel it. Now folks, the numerator doesn't have anything left. So you have to leave a 1 in that case. And we'll have x squared plus 5 on bottom. All right? Okay. Now, next up we're going to talk about multiplying. So turn to the appropriate page in that packet. Multiply. So, multiplying rational expressions. Example 1, the only example that I have is x squared minus x minus 6 over 3x squared minus 12 times x squared plus 3x minus 10 over x plus 6. Now we're going to do it a little bit differently than I have on the paper. We're going to factor these in line. Okay, well actually, I'll show you what I mean in a minute. So down here, we're going to factor this one, x and x. Two factors of negative 6 that the negative 1 are negative 3 and positive 2. Now down here, we can take a 3 out, and that leaves me x squared minus 4, which is further factorable as 3 times x plus 2, x minus 2. Okay? So I'm going to mark that out, and we're not going to use it. We're going to use something else later. Okay, this one, x and x, two factors of negative 10 that to positive 3, x plus 5, x minus 2, and the x plus 6 is unfactorable. So now what we're going to do is I'm going to rewrite this cleaned up. So x minus 3, x plus 2, over 3, x plus 2, x minus 2, times x plus 5, x minus 2, over x plus 6. Now, what we're going to do is you always cancel what you can within the fractions. So here, both of these have an x plus 2 in them. So I'm going to take my red, I'm going to mark out the x plus 2's within the fraction. Okay? Then I'm going to take my green, I'm going to cancel what can be canceled diagonally. You always cancel what you can diagonally. So both of these have an x minus 2 in them. Okay? X minus 2, x minus 2. So those will cancel as well. Okay? So we will have x minus 3 when we're done. Oops, and then we multiply across. Okay? So this will give me x minus 3x plus 5. And down here, we'll have 3 times the x plus 6. Be sure you put the x plus 6 binomial in parentheses. Okay? Now, I'm going to scoot this over. I'm going to do division on the same side by side with it. Okay? So give me a moment while I see how this is going to look. Okay, so let me get out the division. I'll do example 1. Divide. Example 1. X squared plus 7x plus 10 over x plus 8 divided by x squared plus 5x plus 6. And the power cord to my computer is behind me, so I'm going to remove it. Lest I trip over. That's part of the problem. Okay, so I'll just get it out of the way. And to be able to keep the screen, I have to press the space bar every so often. Or touch the computer or do something to let it know that I'm still here. So what we're going to do is what you would do is you're going to leave this one alone. You're going to flip the second fraction and set everything up to be multiplied. So the first one stays as it is. And then this becomes times. This wasn't x plus 6, this was x minus 9. So we're going to flip it to x minus 9 over x squared plus 5x plus 6. And then it's going to be kind of like this one, so we're going to factor it. So we have x and x. 2 factors of 10 to the half to 7 plus 2 plus 5 over x plus 8 times x minus 9 and x and x to factor the bottom. 2 factors of 6 to the half to 5, positive 2, positive 3. So plus 2 plus 3. Now what you do is you cancel what you can between the diagonals, within the fractions. Well, nothing cancels within either fraction, but you do have something that cancels diagonally, and that is these x plus 2's. So, cancel them. And we're going to have the x plus 5 times the x minus 9 in parentheses over the x plus 8 times the x plus 3. Parenthesis, parenthesis, and we're all done. Okay? So that takes care of the multiplication division. What's next is we're going to talk about adding and subtracting with like denominators. All right. So, addition and subtraction with like denominators. So add or subtract as appropriate. So, example 1. I have x plus 4 over x plus 6 plus 2x minus 5 over x plus 6. Now, what we have here is a pair of like denominators. So all you do is keep the denominator that you have. And then you add your numerators. So 2x and 1x and 2x is 3x, and 4 take away 5 is minus 1. Or another way of showing that is just put the x plus 6 down here. So let's do this another way. You could put the x plus 6 down here, and then you've got x and 2x is 3x's. 4 take away negative 5 is negative 1. Okay? It's similar to arithmetic fractions where if you had the same denominator on bottom, you kept the denominator and added your numerators. Okay? You guys can see a reminder of how it works up here in the corner. Okay, arithmetic. A lot of what's going on here is similar to arithmetic. So example 2, we have x squared plus 7 over 2x minus 7 minus 3x plus 9 over 2x minus 7. Now what happens here is you have a negative that must be distributed to the second fraction. So you should have x squared plus 7 over 2x minus 7, and then you're going to have plus negative 3x minus 9 over 2x minus 7. Okay? Well, you got what you're going to have here now is x squared minus 3x if you put them in descending order, and 7 take away 9 is minus 2. And then you're going to keep the 2x minus 7. All right, now, we're going to be talking about unlike denominators, but before you can do unlike denominators, you need to know how to find the least common denominator. And then we'll convert the fractions to it, okay? So the next video, another video, is going to discuss least common denominators. And then after that, I will resume that packet.